Hello, I hope you are all fine and enjoying our channel. So, after discussion of the quantum mechanical formula and discussing the effect of Heisenberg uncertainty principle and de-Broglie's theorem, and a little bit about the Hamiltonian operation, or you can say the Schrödinger equation. We know a little bit about the quantum mechanics. Now, in this video, we will learn more about how this quantum aspect is really important for the atomic model. So, basically, in the Bohr's model, we only know the things which is the principal quantum number, and in that model is only gives an idea that electrons are moves in a particular path, and from the Bohr's model we only know the principal quantum number, but there are all other kind of quantum number which is present that we don't know. So that quantum number, like the azimuthal quantum number, magnetic quantum number, and the electronic spin quantum number, this kind of quantum number we only know after the solution of Schrödinger equation. So now you can know the psi function, how its importance, and the solution of the psi function is basically gives the other three kind of quantum number, like azimuthal quantum number, spin quantum number, and magnetic quantum number. Now let's see like how this quantum number comes out and what are the importance of this kind of quantum number. So in this video I just states about these three different kind of quantum number with the principal quantum number. So don't forget to like, share and comment in our channel. So basically I hope that you will learn something and enjoy with this video. Yeah, let's begin. Yes. So what are the content? Now we will discuss about the orbitals and the quantum numbers. The principal quantum number, and which is designated as n, and azimuthal quantum number, which is designated with L, followed by magnetic quantum number, which is designated with ML. And finally the spin quantum number, or it's called the electronic spin state. And next we will discuss about what are the difference, or what is the difference between the orbit and orbitals, right? So orbitals and the quantum numbers. So basically a large number of orbitals are possible in an atom. So what does it mean? It means that an atom, it consists several number of orbitals depending upon the principal quantum number. So qualitatively these orbitals can be distinguished by their size, shape and their orientation. An orbital of smaller size means there is more chance to finding the electron near the nucleus. So you know that nucleus is present in the center of the atoms. So electrons are far from the nucleus. That means the size of the orbital is huge, or it increases. So near to the nucleus, the electrons of finding is very high. Similarly, the shape and orientation means there is more probability to finding the electron along a certain direction than others. So you can see this probability factor when we will discuss about the psi function. That psi is basically give an idea about the probability of finding the electrons in each quantum state. Now each orbital is designated about the three quantum number, which is designated as n, l and mn. You need to remember this factor from this slide. There are three quantum number which is basically very important to to find out about the size of the orbital, shape of the orbital, and orientation of the orbital. So size gives about the idea from n, shape gives the idea about L, and orientation gives magnetic quantum number, right? Okay. So next is principal quantum number. The principal quantum number is the n, and which is a positive integer value. That means n value is 1, 2, 3, 4, like that. The principal quantum number determines the size and the large extent of energy of the orbital, and this consequence you will get an idea when we will solve about the Bohr's model. And in the Bohr's model, it's easily states that the principal quantum number is highly related with the energy state of each orbital. Next, the principal quantum number is also identifies the shell. With increasing the value of n, the number allows the orbital which is increases and are given by the n square value. All the orbitals of the given value of n constitute with a single shell atom, and they are represented by the following letters. In your class 10th level, you know the values of n when increases n equal to 1, 2, 3, 4. It designated the shell number which is K, L, M, N, etc. Right? So when n equal to 1, which is correspond to the value of shell is K. When n equal to 2, the next shell which is designated as L. When n equal to 3, that designates the state of the shell which is M. Like the way when the number of n equal to 4, then shell is N, right? And the size of the orbital increases with increasing the principal quantum number of n. That means when n equal to 1, the K shell is smaller, but when n equal to 4, the n shell is very larger. So you can see the shell size is increasing from K to N. That means when n1 equal to 4 will go, the size of the shell is increasing. Okay. Next is azimuthal quantum number, which is designated as L. The azimuthal quantum number L is also known as orbital angular momentum number, or which is subsidiary quantum number. It defines the three-dimensional shape of the orbital. That means it gives the 3D arrangement of the orbitals. For a given value n, it gives the L value which is 0 to n minus 1. That is, if you know the value of n, then you can find the value of L. How? Now you can see the value of L is 0, 1, 2 to n minus 1 value. For example, when n equal to 1, the value of L is only equal to 0. For n equal to 2, its possible value L can be 0 or 1. So you can put the value of n equal to 2, right? And then you can find one value is 0 and another value 2 minus 1, that is 1. For n equal to 3, the possible value is 0, 1 and 2. Each shell consists one or more subshell or sublevels. The number of subshells in the principal shell is equal to the value of n. For example, the first shell n equal to 1, there is only one subshell which correspond to L equal to 0. There are two subshells when n equal to 0 and 1. The second shell n equal to 2 and 3 is a third shell thereon. Each subshell is assigned as the azimuthal quantum number L. The subshell correspond to the different value. Now how we can get this different value? First we need to know the n value, and from the n value we can find the L value, different L value. And if we can find the different L value, like L equal to 0, 1, 2, 3, 4, and then we can designate this number as a subshell of S, correspond to value of 0, P correspond to the value of 1, L value 1, D subshell correspond to the value of L equal to 2, and F subshell correspond to the L value is 3, like that way, right? Now in this table you can find easily the different N and L value which is designated as a subshell notation. Now what does it mean? When N value, principal quantum number, is 1, we can find N minus 1 equal to L value, right? So L value is 0, then the subshell notation is 1s. Next, N equal to 2, the principal quantum number is 2. The subshell L value when is 0, that means S. When N equal to 2, we can write here 2. The subshell value of L equal to 1, we can give the value of P, because after S we can find P, right? Here you can see S equal to 0, P equal to 1, D equal to 2, and F means 3. Okay, now here you can find 4. 4 is the principal quantum number, 4, and L value when it's 0, we can write S. That means 4s is the subshell number. Next, now you can tell me what is the value of N and L for the subshell of 5D. Yeah, did you find that one? So this means N value is 5 and L value is correspond to 2, right? Because S equal to 0, P equal to 1, and D equal to 2. So D means 2 and N value is 5, is the principal quantum number. Now you can say when N value is 5, L value is 2, we can write 5D subshell. Okay, now the magnetic orbital quantum number. So magnetic orbital quantum number ML gives the information about the spatial orientation of the orbital with respect to the different coordinate axes. For any subshell, we can find 2L plus 1 number of value of ML, and ML value is designated as minus L to L value. Thus, when L value is 0, only one permitted value of ML equal to 0. So, how many number of S orbital is 2 multiplied by 0, we can find 1 S orbital. When it's 1, we can find 3p orbital, like that way. So each orbital of an atom therefore finds a state of different set of value, which is NL and ML. An orbital describes the quantum number when n equal to 2. Then the value of L equal to n minus 1, that is 1, and ML equal to 0. This is the orbital of the P, which is the subshell of the second shell, and following chart, right? So in this following chart, we can find the value of L equal to 0. The subshell notation is equal to S. So number of orbital equal to 1. Like that way, the value of L when it's 1, we can find the subshell value is designated as P. This subshell value comes out from the azimuthal quantum number, right? And then this gives the final value, how many orbitals is present, right? Now the electronic spin state. Electronic spin, these three quantum numbers leveling of the atomic orbital, and is used for define the energy's shape and orientation. You need to remember that principal quantum number gives the energy azimuthal quantum number gives the actual shape of the orbital, and the magnetic quantum number gives the orientation factor. But all of this quantum number is not enough to explain the spectral study. And that spectral study means when it was done by Zeeman effect, like they have used different magnetic field and electrons are split in different lines. So that model is comes out from the idea of the spin quantum number. So George and Samuel is actually gives another quantum number which is called the electronic spin quantum number. Yes, and its important is basically electrons when it moves, it's actually spin on its own axis, like a earth. You can know it's always spin on its own axis. So this is the momentum of an electron, and it's basically called the vector quantity. So ms value is also designated as plus half or minus half value, and that is mathematically proven. Normally, and this plus half and minus half value is also written up as a upward direction arrow or downward direction arrow. The upward direction arrow is called the spin up or spin down motion of the electron, right? So as a sum of what we learn, the n defines the shell and determine the size of the orbital, also a large extent of energy of the orbital, right? And there are n subshell which is also correspond to the different nth level, and L identified the subshell which is determined the orbitals. There are 2L plus number of 1 orbitals of each type of subshell. So then if we know the L value, we can designate it as different shape, which is SPDF, different shape of the orbital. The ML value is very important because it gives the orientation of the orbital, and for a given value of L, ML has 2L plus 1 number of values. Finally, MS is the electronic spin state, refers the orientation of the electronic spin on its own axis. Next, the orbit and orbital concept, and it's important. So orbit and orbital are not the synonymous. An orbit is proposed by Bohr. In its Bohr model, the circular path is considered as a orbit, where the electrons are moved. A precise description of the path of electron is impossible according to the Heisenberg principle. So the orbit concept is only possible according to the Bohr's model, and it gives a classical physics model where electrons is moved in a circular orbit. But according to the quantum mechanical concept, orbital is much more important, because an atomic orbital comes out from the quantum mechanical concept, and it refers that the electron not only a particle but it also have a wave motion, and which is designated as a psi factor of an atom. So we can say that orbital concept is much more important rather than orbit, because it's not actually the circular, but it has its own shape. Like later you will know the S have a spherical shape, P has a dumbbell shape, different shape it has. And it is characterized by 3 quantum number, which is N, L and Mn, which we have discussed before. And the value depends upon the coordinate of the electrons in different axes. And size itself has no physical meaning, but chi square is the probability of function. It gives the different orientation in different space. And later scientists have developed the chi square function. It gives a different solution, and from there we can also find the orientation of the electron in different space. So now you know the concept of orbital is very important rather than the orbit, because it's only gives an idea from the Bohr model, but orbital concept is much more prominent, and it comes out from the quantum mechanical aspect, and it's much more relevant from nowadays. Now here Bohr's concept, according to the Bohr's concept, orbit looks like this. It's totally like circular, right? And the orbit, you can know that the concept of orbit, the 2 electrons in first path, second path is 8 electron, and the third path it has 18 electron, like that way. But when the quantum mechanics comes out, it gives much more prominent idea that the state of degeneracy, you can find that the orbit is also splitted in presence of magnetic field, like one line is gives much more splitting, and it splitted in several lines. So how does it comes out? That means there are some other factors is related. That's why the other quantum numbers is comes out. Not only the principal quantum number, there are azimuthal quantum number is comes out, and also the electronics magnetic quantum number and spin quantum number. So according to the quantum mechanics, the orbital concepts look like this. The s orbital is spherical, and the p orbital looks like this. When px is x-axis, like this looks like in this shape, and then 2p, and then 2pz, right? So here in 3 different axes they have designated the value px, py and pz. It splits in different line, and it's called the orbital. Now you are much more clear about the concept of orbit and the orbital, because it gives the different directions, z direction, and then the y-axis direction, and then the x-axis direction, right? So in a conclusion, the n level of shell is determined the size of the orbital and also large extent of energy of the orbital. There are n subshell is the nth shell, and the L value is correspond to the azimuthal quantum number. There are 12 plus 1 number of each value is depend, which is correspond to the different state. And how many subshell can be possible? The ML is also designates the orientation of the orbital, and its value is depend also the 12 plus 1 number of value. The MS, it's also referred the orientation of the spin in different state, right? And it's split actually in presence of magnetic factor. An orbit is only proposed by the Bohr, and it's basically in a circular path around the nucleus. On the other hand, the atomic model is basically considered by the quantum mechanical aspect, then orbitals comes out. So yes, thank you. So feel free to contact me with my email ID. I hope you can enjoy this. So don't forget to like, share and subscribe my channel.